So in today's final thesis presentation, we'll be talking about open source projects. So in this whole discussion, we'll see what exactly open source projects are, and we will dwell deeper into how sprint duration affects open source projects. And we'll do the comment analysis, and we'll see the effect of issue prioritization in open source. So during all this process, we'll be using data analytics in Agile Project Management. So let's start. So first and foremost, we'll talk about what are proprietary softwares and what are open source softwares, and then we'll see the software development process. We'll see the Agile methodologies, which is now the trending methodology in software industry. Then we will see research gap after looking at the literature review, and then we'll understand, in order to answer the research questions, which research methodology and design we should go ahead, and then we'll analyze each and every research question. Then we will come to conclusion. So first and foremost, let's understand the software development industry. So when we talk about software,
It's
we
10
can
o'clock.
everything which comes in our mind is like the apps which we use, or the for example, we watch movie on a VLC media player, or we browse internet on a web browser. So everything is software, and software is a way by which we control the hardwares. So during the process of software development, we write codes, then we basically test it, and then we uh, ship it to the customers. They use it, they give a feedback, and then we keep on improving that. So uh, nowadays it's very trending to use agile methodologies, because it solves a lot of use cases of software development challenges. So, so first and foremost, let's talk about proprietary software. So, if we use Netflix, it's a proprietary software, because if as a user or as another software engineer, I want to change the code of Netflix, I cannot do it. So, proprietary software are softwares which are owned by companies. For example, Microsoft Windows, which you might be using Microsoft Windows, uh, or you can say Apple Mac is operating system, which is basically a proprietary software, or we can say Adobe Photoshop. So there lot of tons of proprietary softwares are there in the market. Now the question arises, what are open source software? So open source software comes from the vision of uh, open source uh, open source uh, um, movement. So that particular movement was uh, raised. Basically, that particular moment came up when there was a duopoly and oligopoly of various software companies. For example, Apple, IBM. So there were some bunch of software engineers. They thought that we should have something which will do a kind of community service, and that particular software is going to be freely available. For example, we have Microsoft Windows, we have Apple. So these two are proprietary software. But on other hand, we have Linux operating system, which is a open source software. So the best thing about a Linux software is that uh, it is open source. Anyone can look at how that particular software is working, and they can modify it, and they can redistribute it. So this is the crux of open source software. To give you more examples, uh, where there are very lot of softwares which are basically used by websites. So websites are hosted on a web server. So that particular software is called as web server, and web servers, many of them, for example, Apache is a web server which is open source, and which is widely used. For another example, we can see in the screenshot is basically JBoss. Spring Boot is there. We have got Red Hat is there. We have got Redis. So these softwares are not directly being used by customers, but these are used by developers who make their work easy. Rather than writing each and everything from scratch, they use the open source software. So let's move and talk about how open source has contributed into the world. So if you look into the surveys, then 99% of software developers believe that open software is basically essential for innovation. So if you talk about statistics, then 78% of businesses are using open source software, and 70% of developers said that open working on open source software has improved their skill, and more than 90% developer rely on open source components. One of the very key and very important thing to mention here is that Android has become the most used operating system in the world nowadays, and this is a open source software. And as you can look into this particular image, this image states that as the adoption of Android is increasing, there are a lot of developers who are using different software components which they are using into their application and softwares. So if you look into this particular graph, then we have got retrofit is there, we have got counter JSON. So these are the components of software which is open source. So what developers typically do, they use this open source software component and they plug into their app, and then they uh, use this particular software component to do basic operations of their app. So this is how software open source has been contributing to the world. Now let's talk about agile methodology. So when we say agile methodology, this is something which is has been the most popular methodology of software development in the industry. So it basically focuses on the iterative development uh, of the software. For example, if you look into this design, which if you look into this graph and image, so you can see that there's a game which is to be made. So how this game is going to be shipped to the customers? So there's going to be a lot of process. For example, there is a product manager who says that this feature of addition of a button should be there in the game or on any software. Then that he will basically create a requirement, and that particular requirement will come from different project managers, and what it will basically get aggregated in the product backlog, which means that these are the product features which we want to develop. Now there's a person called a scrum master who basically looks into all the product backlogs and basically creates a sprint, which basically is a kind of time duration which typically lasts from uh, 14 days to 4 weeks. So basically this sprint will be will be a set of uh, product requirements which scrum manager will basically lead, and he will assign these requirements to different developers. So once this particular sprint is complete, then this particular sprint task will be completed, and after that again another set of tasks will be taken from the product backlog. So it's also important to mention that what is scrum. So scrum is basically a process in which iteratively software requirements come to the scrum manager from the product manager, and he ships the product feature, and he basically asks respective developer to work on different product features. He asks the QA analyst or the testing team to test the feature, and then when the feature is fully developed and tested, then he can simply release that set of tasks. Again, the same process will happen. So this basically process of uh, daily scrum is basically called a scrum, in which every developer software engineer sits with all the peer developers, and they do a meeting on a daily basis, which is called a scrum. Kanban is another way in which basically software products are basically the features are shipped, but there is no time limit and there is no concept of 14 or 15 days. Whenever the feature basically is done and certain set of features are completed, it will be shipped to the product feature. On to the next section. uh, in this section we'll talk about research gap. So during the research literature review, we saw that Rahman M and other researchers have uh, studied the comparison between proprietary software Scrum and the open source development. So they showed that typically open source software development, in that basically the developers are geographically dispersed. They are located at different location, and they don't have any fixed structure. So some developers will be very highly skilled, others will be low skilled. So the researcher also highlighted that there is no timeline definition on open source software development, and the researcher didn't talk anything about the sprint duration in open source software development. Now moving to another section. uh, every issue or every bug in the software can be marked as high priority or a low priority bug, which means that whether that problem in the software has to be fixed at the immediate urgency or it can be fixed later also. So as demonstrated by researchers Nugent, Duke, and Cruises, that preparatory softwares development, in which the developers are basically paid by the firm, they prioritize the uh, such issues in order to meet the deadlines. So this effectiveness of issue prioritization on resolution is not basically understood in open source software development, and that was basically missing in the research. Next, moving to the comments and how what are the sentiments of a developer with respect to the issue. So whenever there is a issue and the problem in the software, peer developers basically comment on that issue, where they put some suggestion, they write some information whether this uh, issue can be fixed and how it can be fixed. So it is typically it is a normal notion between developers that if there are a more number of comments in that issue, the resolution time is going to be high. So there's a research done by O2, Marco, Adam Bram, and other researcher, which shows that if the number of comments on the issues have a sentiment of joy and love, then the resolution time is going to be low, which means that developers, if they feel good and they feel excited and they feel loved, it means that they are more willing to solve that problem and fix the issue in uh, very small time. So the question raises that if there are more and more comments on that particular issue, does it affect the resolution time? So this is going to be the research uh, problem which will be looking at it. So so if we write into this, then the question comes like this: that do open source projects have longer sprint duration than software proprietary software? Which means that typically the proprietary software uh, have a sprint duration of 4 weeks or less than that. So we want to check whether that open source software have sprint duration more than that, because typically open source software don't have scrum master who can channelize the team. So this is going to be first research question. Now the next question is about issue prioritization. That does uh, a issue which is marked as high really resolve uh, faster in open source domain? So we are basically checking that to what extent does the accurate prioritization of the issue leads to the faster issue resolution. So we want to see that if the issue is marked as high or high priority, does it really take less time to resolve? Now the next question comes to the number of comments. As we discussed earlier, that is there any correlation between number of comments and the time of resolution of the issue? Now moving to the next section about literature review. So there are multiple research have been done. For example, the practice of adoption of agile methodologies tells that there's a 2 week is the good starting point of any sprint. So we can have a sprint which spans from 14 days, which will be 14 days. But another research says that the sprint duration shouldn't exceed 4 weeks. Now let's talk about why having a sprint duration is important. Another research by P.T. Robinson and Bisham says that if we don't do that, then there is going to be a poor coordination between, and especially it happens when there is a contractual relationship between those two companies. Uh, Another research done by Lavazzi, Luigi, and Morcus illustrated that they uh, they successfully switched to Scrum in open source software, and the developers were geographically distributed. But this basically analysis was done only for one software, Maxim, and this whole thing was basically led by a very skilled team, and it was led by a Scrum master. So I think uh, we can say that there has been a research around open source software sprint duration, but if you look at another research which says that sprint duration in open software is also based nowadays based on assumption. So this we need a clear answer that what is the typical duration of sprint in open source software. Now talking about the blocker issues. So whenever we have a issue or a bug in the software, it can be marked at a priority by which the developers will look into it. So based on the urgency, the issue can be marked as trivial, low, medium, high, critical, and blocker. So uh, there's a issue which basically research done by the Swami Naka and I Pirara, which shows that it is how it is important to give a priority to a production issue. It means if a issue is in production, which means that software is running in the production, which is basically distributed, and users are facing the issue with that particular problem and the bug. So it is also important when there is a contractual relationship between uh, the vendor and the software developer. So it basically a kind of business. There is a problem in the business software business use case. So this is basically studied by the researcher Deneva, and there's a research has been done, so which tells the importance of prioritization of issue in a contextual relationship. Now, we looked at research done by Popley, Archona, and Sharma, which basically tells that it is very important to prioritize the issue, but they didn't talk about does that the prioritization of issue really is going to affect the resolution time or not. So that we have to look at. Moving to the next section, so if you look into the screen, so here we have got a screenshot of a comment. So basically this is a comment section of a issue on the GitHub, which basically tells that how developers basically communicate. So it's a kind of communication channel in which various developers uh, put information to other developers, and they are asking for information if you look into the screenshot. And typically the comments are encouraged, which uh, which is a kind of effective communication uh, between the software developers. And another research basically done by O2 said that developers are basically they are firefighters. They don't fight on the problems, rather than they collectively try to resolve the issues. So moving to the next section, will be looking at what design methodology we are going to be using. So we are driven by positivism research paradigm, which simply means that we want to know the reality and we want to measure the reality. So this whole research is basically done on a secondary data, which is basically compiled by TAWOS. So TAWOS is basically a repository of 5 lakh issues, and 40 from the 40 open source repositories, open source repositories, and it's the most versatile and comprehensive repository available on the internet. So that's why we have chose this particular database in which we will be doing our further analysis. So what we did, we basically went to the GitHub page of that repository, and then we downloaded the SQL file and we imported that SQL file. So in order to do the research, so what we are doing, we will be first running the SQL command, and then we will be basically extracting the data, and then we'll do the further analysis. So before we do the analysis, let's understand what is a sprint, what is a comment, and what is a issue in terms of the database, right? We will do that, but it's also important to understand that what is the right sample size. So if you look into the database, then we have got a good resource. So resource was the prime thing that we actually we were inclined for the ideal sample size. So also we wanted to have a good significance level of 95%. So that's why we wanted to have good sample size. So we exactly don't know whether the sample is right or not, but in the further research, when we will be doing research, then we will analyze the sample size also. And uh, we also wanted to have statistical power. Basically, we wanted to corrupt the possibility of not basically understanding the null hypothesis. We wanted to be sure that the null hypothesis uh, is right, and it is not falsely taken as the truth. So let's talk about the data mining strategy. So basically, we have got this issue, and this issue is basically, issue is a table which basically tells that there is a task, and this task has to be done. This problem, so this task can be anything. It can be a improvement in the software, it can be a bug, it can be a story which basically tells a feature requirement, very big feature requirement, and epic, that is lot of features are there which is called as an epic. So every issue is associated with id. It can have a description, it can have a priority, it can have an estimation date, it can have a resolution status and date, and story point. Story point tells that how much time it will take for the issue to get resolved. Now yeah so now we talk about sprint. So sprint is basically, as we mentioned, that it is way iterative way to take task from the backlog and deliver it as a feature requirement. So every sprint has an id, it has a name, uh, it has a start date, and which it gets started, and it has an end date where it is planned to end. But the sprint may or may not end on the end date. So that's why we have a completed date in which really that sprint completed. For example, if there is a sprint which is planned for 14 days, but it took 16 days to deliver all the issues, so then the completed date is going to be 16 days according to that. And we also have a state whether that sprint is actively running or it has already been run. Now, moving to this comment table, we have this, as we mentioned, that comment is a way to communicate between team members. So every comment is associated with an ID. It has the comment text. It has an issue ID. It means that how that comment is related with that particular uh, issue, and who has commented is basically related with the author ID, and on which date he has commented. So that is, so this is the structure of the table. Uh, we can also look at this high level structure, which is not very relevant with our analysis and research, because it has too much of data, but we are more interested in this issue table and how it is related with this comment table, and then we will be, and how it is related with sprint. So this sprint is related with an issue. Basically, it has one to many relationship, and the issue is related with a comment. It means that a comment will be related with an issue. So this is the structure. Now let's move to analysis and implementation. So in general, we will follow a particular guideline. The guideline will be how this basically the structure of the analysis is going to be. So first, basically, we'll be running a SQL command. So it is the way by which it will extract the required data from the database. So for example, if you look into this presentation, that select star from t towards database.sprint where state is active. Basically, this is a command which we will run, which will select all the sprints which are in the active state. So how it looks, basically, if you look into the screenshot, so I have added this screenshot. This looks something like this. So we, whenever we run this command, we press this, we run this command, select star from this issue, table issue, and then we get the data. And what we can do, we can export this data by clicking on this button. So once we have extracted this data, it is also important to filter the dirty data which will contain invalid data, null or undefined. So that is also, once we have exported that data, we have data with us, then we import it into Google Sheet for the inferential analysis. So inferential analysis will be done on Google Sheet. We could have chosen Microsoft Excel, but I'm more well versed with Google ecosystem. That's why I'm using Google Sheets. But we can use that same file into any of the worksheets. So let's move to this is a screenshot of uh, how the data was collected and how the inferential analysis was done. Now let's come to the research question, first research question. So the research question first is that we want to know whether that the sprint duration of open source software project is less than 4 weeks. So why 4 weeks is chosen? Because 4 weeks is the maximum sprint duration of proprietary software. So we want to check whether a sprint duration of open source software is in line with the proprietary software projects. So that's why we chose this particular 4 number. So first and foremost, we'll fire this query. The query, SQL query, is basically select. We want to know how much sprints are there in the database. So once we, if you look into this, then select count from where state is equals to closed. Basically, it resulted into 4,500 uh, sprints. Now we want to know that what is the sprint duration and what was the name of the duration. And we all were only interested in those sprints which are closed. So that's why we put query where state is equals to closed. And timestamp diff is a function in SQL which tells that what is the duration of time in weeks from start date to the complete date. So we run this query. Now after the running this query, we have the data in the form of CSV file. Then we can start with the statistical analysis. So we form the null hypothesis and alternate hypothesis. So null hypothesis is basically we assume that the every sprint duration of the open source project is less than 4 weeks. So this is our null hypothesis, because we are not interested that to know whether that sprint duration is less than a particular value. We are only interested in whether it is, if it is only less than 4 weeks or not. Let's move to the next section. So what we did, we basically did our analysis. I would like to switch my tab and show the real analysis. So here we have this sheet in which we have this whole data with us. So we can see that the duration is 1 week, 2 week, 3 week, and 18 weeks like this, and we have like this. So we can use the critical value method. So the null hypothesis stated here. So we'll be performing one tail test. So why? Because we don't want to know the exact number, but we only want to see the one side of the value. So that's why we chose the right tail test. So we are interested in testing with it with 95% confidence. That's why we have chosen alpha is equals to 0.5. And as we want to pivot our mean at 4, so that's why we have chosen the null hypothesis hypothesized mean to be 4. Then we basically looked at the sample size. The sample size is 450, which is also evident from this. And then we use this function of using average calling this average function to calculate the mean. Then we used standard deviation function to find the standard deviation. Then we use this formula. Let me show the formula. The formula, yeah. So basically, the formula is here only. So we basically uh, use this formula basically to find the uh, Z score. Now the Z score we found basically is uh, 1.645, which means that the Z score found is 0.938, but the critical value for that Z score at 95% confidence is 1.654. It means that the Z score obtained is at less than 1.654. It means that our null hypothesis is true and we fail to reject the null hypothesis. Now, moving to the next analysis, but we were surprised to know that why the mean of why the mean base was showing 25 weeks. So 25 weeks is a very huge a number when we talk about average sprint duration. So we looked into the interquartile range. So we found that quartiles were Q1 was 1, Q2 was using the quartile function, Q2 was this, and we saw that Q4 was something which was misleading, and Q4 was something which uh, was skewing our data. So we wanted to find what is why it is skewing our data. So we find the dirty data at basically this particular sprint was there. So we looked into the start date. So it started at uh, 0015, which is obviously wrong, and it got completed into uh, 2015. So it basically is wrong. So that's why we uh, simply discarded this data, and we can see we can basically see the average duration of this sprint in open source software is basically 1 to 2 weeks. So we can say that it is less than 4 weeks. So we also wanted to perform this test on low sample size. So what we did, we basically decreased the sample size. So the sample size was 4,500 around. So we did another exercise in which we created sample of half size of the original. So we created two random samples. So these two random samples were of half of the size. So we basically performed the same exercise of calculating the mean, standard deviation, Z score, and interquartile range. So we found that the Z score was still okay in these two samples. We again divided this exercise, and we used another sample which was 1/4 of the original. So we created two random sample, and we again saw that for this the sample mean was 2 2, standard deviation 9, and the Z score was minus, which was really skewed basically. So we wanted to know that why it is so. So basically, when the Z score is beyond a certain uh, negative or beyond certain limit, basically tells that the sample size is too small. So we concluded that this 2,253 is somewhere something which is a good sample size to uh, talk about and to do our analysis. So in general, we saw that open source software projects, the sprint duration is less than 4 weeks. Now let's move to the research question 2. So the in this research question, we actually wanted to know uh, to what extent the issue prioritization leads to faster issue resolution in open software, right? So we wanted to know the resolution duration of the issue, and we wanted to see the priority. So this is the query which we run. So we try to calculate the average. We wanted to find this standard deviation and the count. and also wanted to know the average duration in which that issue was resolved. So there are these number of priorities, I think 10 and 13 priorities are there, which is there in our database. So we run the query for each and every priority. So low was there, we have got empty, which means nothing, no priority was assigned in it. Then we have got trivial to be reviewed, and all these priorities were there. So we run query for all of this priority, and we came up with this particular data. So basically data is here. So we came up with this sample count, average closure duration, and standard deviation. So I would like to show this into the Google Sheet also. So here we can see that this is the data which we have. So we wanted to calculate the standard of error. So standard of error was basically calculated with the help of this particular formula. And now we calculate the standard of error, and we calculated this margin of error at 95% score. So this using this formula, and uh, we basically calculated the margin of error, which basically tells that what is the variation between the error variation between from the average. So so after that we basically got the minimum and the maximum value in which the average mean will lie. So we plotted this on curve. This is our curve, and we saw that for blocker, the resolution type of issue was very less, but for issue which is prioritized as medium, the average time was high. And similarly for the low and uh, empty. So it means that basically, if in open source software, it means that if we are marking the issue in such a way that it is prioritized properly, then it is definitely going to resolve into then that right priority. Although we have some data, for example, if you look at this lowest priority, there is some error, margin of error in this, which states that uh, there is a lot of variation in which this issue was resolved. So if you look into this, the confidence interval minimum and confidence interval maximum is written here. Going back to our presentation, so this is what we have discussed here. Now let's move to the third question, in which we wanted to know whether there is a uh, correlation between number of comments and the resolution time of an open source software. So first we did a SQL query in which we wanted to find out the number of comments on a issue. So we basically queried this comment based on this ID, and we wanted to show that we are only taking those issues which are marked complete, invalid, or resolved, or deferred. It means that the resolution is we know that resolution. It means that the resolution, we know that resolution, it has been resolved, and it's not being worked on. So we basically looked at the frequency number of counts on that. So so when we basically run the basically we formed the null hypothesis and alternate hypothesis over there. So we the null hypothesis was that there's no relation between issue closure and comment count, and the alternate hypothesis was vice versa. So we used the Pearson coefficient correl function in the Google Sheet. I would like to show that here also. So this is our data which was extracted like this, and when we run this correl, so basically we found that this is 0.48, which means that there is a very weak correlation between the two variables. But the problem is that we are only checking for the linear relationship. We are not checking, it can be a non-linear relationship. So that's why we wanted to ensure that there is no non-linear relationship. That's why we drawed a uh, scatter plot. So we can also see it in here that these dots represent the number of comments on a particular duration. So with a particular duration in days. So we are able to see that there is no correlation, but although there are a lot of dots at the uh, x axis, y axis, it's at the x axis. So we wanted to dig this further. So what we did, we basically made buckets of uh, duration, and we analyzed, and we basically fired a query which is there in the research paper, which is beyond the scope of this presentation, so we didn't put it. So we found that there was it was basically related like this. So we have this frequency, so we can say that for issues with duration between 22 to 30 days, there was 968 comments. But if you look at some other examples, say for 4 to 6 down, it was, so there was no strong relationship, and we ultimately concluded that there is no relationship, and which was also evident with this correl function which was telling. Now, going moving to the conclusion, so we can conclude here that uh, sprint duration in open source project is less than 4 weeks, and if we set the right priority of an issue, then there's a good likelihood of getting it resolved at the in the right time frame, which is this planned form. And we didn't found any significant effect of number of comments on the issue resolution. Now we can talk about what things I learned during this whole research process. So I have been working into the software development industries for long, for around 10 years, and working as principal engineer in uh, a proprietary software company. But as a developer, as an engineer, I have used a lot of open source softwares, and I see that there are unsung heroes who keep on contributing to the open source software, and they contribute to the community, and they have a notion of giving back. Uh, Even I have added done contribution open source software. So many developers basically do to gain the recognition. They want to have a prestige, and they also want to some people they want to do to learn and improve their skill. So this is a community driven activity which basically software developers do, and it basically is in line with the open source software vision, which basically uh, is against the monopoly or oligopoly of the software developers, and they software developers don't expect anything in return. And this is a vision to build the community and give back to the world. So why I choose this particular topic is basically I have been benefited, as I mentioned, I have been benefited by the open source software, and almost for me, I use 30 to 40% of open source code in my projects, in my mobile application. And I faced a lot of problems in this. For example, if I face a problem on the component of the software which is open source, then I make a comment. So I don't know exactly when that particular comment will get resolved, or when that issue, if I face an issue, I put an issue, and I basically
It's 11
ask the
o'clock.
developers to fix that issue, but I don't know when that issue is going to. So I am really into this particular domain, and I wanted to explore that how this open source community work basically, and I wanted to debunk some myths which is basically associated in the whole software developer community. So I wanted to explore. Moving to next page. So I wanted to get more and more insight. So that's why I chose a data set which is also open source, and I which will give better insight for me. So that's why I chose this TOWAS database. A database basically to get more and more insights. And as I aspire to become a Scrum Master, and I want to understand uh, how to basically channelize team, what are the key components which should be kept in mind to get the things and the features in most less time, and most in a most efficient way, uh, to use the right word. So that's why I wanted to understand it from the perspective Scrum Master. And uh, there is going to be time when many proprietary software companies have to work with other teams. So what is the sprint duration they should have, and the other company should have sprint duration, and they should be in sync with. So this is something which has to be understood, and open source sprint was to start with. That's why I looked into the open source software. And there are various perceptions basically between the open source community. So I wanted to understand whether the perception is right or not, and I wanted to use the data analytics techniques to debunk the myths, and to really understand that whatever perception which we developers have, we I wanted to understand the hypothesis and either to reject and fail that hypothesis. So it has been a very a wonderful experience going through all the literatures which I had, and which gave different perspectives about open source projects. And it has really helped me learn a lot in terms of open source projects, the agile methodologies, and my way to become a scrum master, uh, and also to help the community. Thank you so much.